Good morning, everyone. Thanks for joining our last webinar for the year 2020. The topic is fundamentals and overview of electrical equipment maintenance. Thanks for taking your time and attending this webinar this morning. Just a quick disclaimer, this is meant to be a very fundamental and a basic electrical equipment maintenance where we discuss a few things about going from reactive maintenance to proactive maintenance practices, and then the importance of codes and standards and the regulatory requirements and the compliance needs as it relates to that. And then we'll also touch on a few electrical anomalies and references from NFPA 70B, which is electrical equipment maintenance standard, and also ANSI NETA maintenance technical specification guidelines. Those are the things we're going to cover today. And then if the time permits, we'll take questions at the end. Okay. So without further delay, the next slide here is just a quick introduction of myself. My name is Bhanu Srilla, as some of you know. I'm the Director of Technical Marketing here at Grace Technologies. I've been, from the background standpoint, I have an electrical engineering degree and also have diplomas in technology management, and I've spent about 20 plus years in power generation and distribution industry, working primarily into electrical switchgear and control systems, both in IEC and ANSI world. I've been with Grace for more than 5 years now, which is 5.5 years now, and my credentials, I'm a certified electrical safety compliance professional from NFPA, and also I'm a certified maintenance reliability professional from SMRP, and also a CRL from Reliability Web. Other than my full-time job, I also sit on the standards technical panels for UL 508A standards, 1436, and then 61010 as well. Okay. So the topic outline, as I mentioned about, is going to be very fundamental stuff on electrical equipment maintenance. We'll highlight what's the importance of proactive maintenance work when compared to the reactive approach, and we'll talk about the impact of regulatory and enforcement. And additionally, whenever we talk about maintenance, we also try to see there's a safety angle to it, which we'll discuss in a little bit detail as we go through the presentation. And we'll also look at ANSI, NETA, MTS standards, and NFPA 70B standards, what those guidelines are, and also take certain references to occupational safety and health administration, CFR 1910 as well. So lastly, we'll touch on few critical equipment failures and few methods or ways on how to avoid them. Again, we're not going to go in depth on reviewing the entire 300-page booklet of ANSI, NETA, MTS, or NFPA 70B standard, just saying again, okay? So before we go into the details of the presentation, I just pulled out some information. I think some of you might have already seen this slide. This is taken out from NFPA research done in 2018. As you can see, there are two elements to it, as I mentioned, from the electrical equipment maintenance. One is the safety angle, and one is the damage to the assets or the property itself, right? So let's take a look at the safety standpoint. If you look at the direct exposure of electricity, this is from the research done by NFPA in 2018. There are about 417 fatalities in a 5-year period from 2012 to 16, and 80% of the fatalities in construction and repair, which is the primary area of focus, as what Grace, as we work into some of those customers, mostly in industrial setups. And also the last two bullets, 36% of these injuries are primarily industrial premises. And the last but not least, which is primarily important here, because most of this, about 1/3 of these injuries, again, occurred in installation, maintenance, and repair functions, which again goes back to lockout, tagout, or without performing the maintenance tasks around the equipment, or people being exposed to those hazards, right? So these are some of those things from the safety standpoint. And if you go to the next slide, then there is another report from the NFPA 70 itself, which is from the damage standpoint from the property fires, right? When you look at the property fires, there are about 37,900 fires reported in a 5-year period from 2011 to 15, and there were about 7,700 of those structural fires. And as the last bullet, or the last point, as you see on the slide, about all this damage, property fires and surge, there's about 24% of those directly attributed to electrical distribution and lighting equipment. That's one of the primary focus areas what we're talking today, right? So that's the reason I want to just bring some emphasis about why this data is critical, right? So again, this is one of the things from the previous slide. Electrical distribution and lighting equipment, as you can see in the slide here, contributes about 24% of the fires, and then the 55%, which is pretty high as you look at the direct property damage. So property damage is pretty significant because of electrical distribution and lighting equipment causes of the failure, structure fires that leads to these damages. Okay. So, and also there's one more table that's been published on the same report, which is quite interesting. They also identified the source of ignition as they relate to this fire accidents, right? So as you look at this top 24%, 640 of those contribute directly to electrical distribution and lighting equipment, which is on the top percentile, and wiring and related equipment, transformers and power supplies, lamps, bulbs or lighting, and then the cord or plug equipment, right? So if you look at all this list, everything is what we do interact on a day in, day out basis. These are the equipment types, what industrial facility will come across on a day in, day out basis, or the maintenance or safety personnel work with them on a regular basis. And also those are the equipment that requires some level of maintenance that has to take place, okay? So let's take a look at why the data is important, right? So the data is important because what is causing all this? I mean, we've been serving this industrial space for over 27 years now from Grace Technologies. And as we go and talk to our customers, we did a survey that asked basically, what are the reasons of these failures or the safety incidents and hazards, right? So the primary things we identified of the these categories. One is the reactive work. Next is the production pressures, then the human error, and the untrained workers, where the workers are not properly trained on the equipment or don't have the proper skill sets to do that. And then the hazards as a result of unmaintained equipment is one criteria. And the last is complacency of the workers itself. So if you look at all these things, the two things that really comes into highlight here is one is the reactive work and one is the hazards as a result of unmaintained equipment, right? These two things. One is reactive work, again, can be because of the production pressure. I mean, it's like a chicken or egg conversation, right? So what happens is reactive work comes into play because the equipment is not properly maintained and things shut down chaotically, and then they need to go and attend to that. That puts a lot of production pressure, and that leads to some sort of shortcuts people try to take to just keep their uptime and put the things fixed in a timely manner. So that leads to these accidents or incidents. And then the hazards as a result of unmaintained equipment. Suppose, for example, you take electrical personnel or a technician working around this equipment, they're going to expose themselves to that danger that's already imminently present within that asset itself. So hazard also could be a result of unmaintained equipment where you're exposing your personnel to the hazards itself, okay? So quick maintenance fact check. Maybe when we asked most of our customers, why do you do a maintenance on your equipment, right? So there's four things. So one is equipment shutdown. So I'm not performing the maintenance unless it's shutting down. That's more like a reactive approach as what we talked about. So the people go and perform the maintenance task because something broke down, they need to go and fix it. Then second thing is the physical signs of imminent failure. They go and see there's a burning smell, or there is the hot spot, or there is some anomaly that they can notice around the equipment while performing the equipment maintenance or doing route-based inspections. That's one of the reasons. And then some people don't know why they're doing it because my boss asked me to do. And last but not least, people do it for documentation purpose. Because as I mentioned, there is so much to say about the documentation requirement when it comes to both maintenance and safety, that they need to ensure that the equipment are maintained and that is documented properly to ensure that the personnel are not exposed to those hazards, okay? So why maintenance is a need in the real world, right? So it basically supports facility operations and production. That's the first thing, right? You need to make sure equipment is running to your optimal performance and your production facility is supported with whatever type of equipment you're trying to use. Maybe a transformer or a MCC bucket or a power distribution board or a low voltage or a medium voltage switchgear or a variable frequency drive, any type of equipment, electrical systems that needs to be maintained to ensure it supports the main function what it's been designed to, right? And then ensure the equipment performance to design spec. This is primarily about whether your transformer is designed for like 20 years or 30 years, is it giving that longevity of that lifespan for that specific equipment? And then you want to avoid the unplanned downtime because you don't want the systems to shut down chaotically at their own course. You want to make sure that they are being put in place and they're maintained to avoid that unplanned downtime. And then extend the equipment longevity, right? So we talked about maintaining the equipment will lead to longevity of the equipment, to the design lifespan of the equipment itself. And the last few things are low cost, total cost of ownership. This is primarily important because you don't normally when you make this buying decisions within your facilities, people always look at the upfront cost. They don't look at the total cost of ownership, which takes into consideration the maintenance intervals and what needs to be done during the periodic inspections or the preventive actions that need to take place, right? And last two things, comply with the regulatory needs, and then keep the personnel safe. So you need to make sure that the people who are working on this equipment are not exposed to the hazards and they're working on a safe environment. This is actually the compelling reason why many facilities do the maintenance on their equipment, right? So let's take a quick look at maintenance strategies, right? So whenever you talk about the maintenance needs, there are like a different strategies industries adopt to. So as is shown on the screen, it goes from reactive to preventive to risk-based to condition-based, right? So reactive is what I talked about. You don't do anything for that piece of equipment. You just go and change when there is the equipment shuts down or run to failure mode, right? And the preventive is you go and perform this maintenance task on a prescribed manner by the manufacturer, specified guidelines, or you take the industry standards such as NFPA 70B or ANSI NETA MTS standards, and then you perform the maintenance based on that specific criteria as defined for that specific categories of the equipment. And then the risk-based is a mix of, you take the preventive and then you also take the failure mode data, and also take the historical information and the environmental factors, and then you make sure that you bring all together and come up with a program that's more like a custom-based program, which will take into consideration the previous historical information, the risk of failure, the previous shutdowns based on the equipment, and then the preventive or the scheduled maintenance approaches, and then you put a maintenance strategy in place. And the last one to the right is the condition-based or a predictive maintenance approach, where you perform this maintenance on demand only. So basically, it's like the new technologies where you sensor, you monitor the system status on a regular basis, and then you combine that with some artificial intelligence, and then you come up with those decisions based on what needs to be done. Not just looking at one specific parameter on the equipment, you look at multiple things. For example, you take a variable frequency drive, you see a temperature anomaly, for example, you're monitoring it, and then you see the voltage and current and frequencies and other loading factors, and you take all those things and then come up with a decision on whether or not a maintenance is a requirement. So what it does is, in the condition-based approach, you're going from not performing the maintenance task on a timely basis, you're only performing the maintenance task as defined by that specific equipment itself. You're monitoring the status or health check on that equipment, and then you're performing the task based on that outcome as what it defines. So, I mean, the bottom two bullets, what I say here is no one-size-fits-all solution, right? There is nothing such thing like you take the condition-based approach and apply it to every piece of equipment. That's not how it works. So it could be certain things that you go from a run to failure, like a light bulb change, or you can go from a time-based, schedule-based inspections or preventive maintenance strategies, and then you go on a condition-based, right? It could be a mix of several things. The maintenance strategies can come together. So it will vary on every industry or a facility by means of how you look at your equipment criticality and then define what maintenance strategy is suitable for that piece of asset itself, okay? So why do facilities get stuck with reactive work, right? There are like so many things what we see, right? So there's new technologies, there's like a lot of standards available for the facilities to adapt to on all this. So why still facilities, when we talk to a lot of facilities, they always say that we are swarmed with the reactive work. So we're in a firefighting mode all the time. So because there's always frequent equipment breakdowns, there are too many work orders they need to attend to, and there's less resources or a limited workforce, we call it here on the slide, or the skill gaps in the employees and the dependency on the third-party employees, right? And also there's no proper planning and scheduling tools available for them. So that gets them to the reactive work. So what happens with that is there is no baseline for the routine work, and then they're in this firefighting mode every day, non-stop. So there's the next slide, it's going to be interesting here. So this is where exactly the Parkinson's law applies, right? So work expands so as to fill the time available for its completion. So if you're always in the reactive mode, it's going to take the same amount of time, whatever it's available, for you to just deal with the day in, day out problems, right? So whenever you're trying to move from a reactive approach to a proactive approach for scheduled maintenance activities, a risk-based approach, or a condition-based tools, you need to set aside some time within your schedules to specifically work on that level. So otherwise, if you don't set aside certain time to just look into those problems, you're not going to get anywhere ahead in the future. So it's still going to get stuck within that routine work of reactive approach only. So just want to tell you, because most of the times we see this, so I don't have time to do this because we have all the reasons, excuses. But again, you need to set aside some time. If it is not properly planned or thought through, you're not going to get there. So that's the point I'm trying to make. Not everyone is trying to fill their calendars. I'm just trying to tell that you need to set aside some time for a change to happen. Otherwise, it will never happen. Okay. So when you look at the maintenance strategy versus risk level, this is very important, right? So when you use different strategies of maintenance, there is a risk component to it, right? So when you look at the corrective or reactive work, whatever you're trying to do, like you're working on a production pressures and you're trying to fix the stuff, there's always a high risk because somebody is going to come behind you and ask you to go and fix the stuff. I need to get it done in 15 minutes. I need to get it done in 1 hour, right? So they're going to define the times because the time is going to be precious for them because they want to come back up and running on the equipment downtime because that's not acceptable from the production standpoint. So you're going to be always at the high risk. When you look at the preventive or risk-based, you're going to be at the moderate risk level because you are shutting down the things, you're taking the things down, and you're trying to do some maintenance activities. The reason why I say it's a moderate risk is there's also a component of maintenance-induced errors as you look at the preventive or risk-based approaches. For example, take an example of you have schedule-based maintenance on a piece of switchgear once in 3 years, right? You go and perform this maintenance. The one thing what we're all trying to say is, I mean, you might have all the skilled personnel or the third-party contractors come and do the work, but there's always going to be that element of whether this equipment has been put back in its original condition as it's been disassembled. That's the question. So that's going to have some level of risk, right? And then the last one is extremely low risk, primarily because you are not touching this equipment unless there is a real need for it, right? So you're going to reduce your interaction with the equipment. That's one piece. And second thing is your personnel are not going to go and do the route-based inspections as they try to go and perform this maintenance task because somebody is going to be in their control room or somebody at their desk. So they're going to have some sensors or some level of continuous monitoring devices or time-based, condition-based systems that's going to monitor and send that data to your SCADA system or a DCS system, which is going to send you alerting techniques. So two things, you're not performing the maintenance tasks on a more frequent basis. And second thing is you're not also exposing your personnel in front of the hazard as they would otherwise with a scheduled maintenance or a reactive work as well. So just want to bring that in, okay? So next is the regulatory and compliance requirements. We talked about the importance of proactive work compared to reactive work. Now take a quick look at what some of those things, right? Whenever we go and talk to facilities, most people don't really understand there is a regulatory requirement or an obligation, I would say, when it comes to the maintenance task, right? So most people think when it's safety, absolutely, as people know, there is like occupational safety and health administration, and there is NFPA 70E standards and safety work-related practices and such. Most people don't know that these maintenance strategies are also linked to regulatory and compliance requirements, which we will see in the next slide. So if you look at 1910-303 subpart S, I'm not going to read through the entire slides, next 5-10 slides. So the points I'm highlighting is, it is a mandatory requirement. It's a regulatory requirement that the electrical equipment shall be free from recognized hazards, right? So there's a heating effect, arcing effect. As you see the highlighted one, there's no damaged parts that might adversely affect the safe operation. The reason is maintenance is not like a primary theme here. Maintenance is subset of the safety itself, right? So people need to be really cognizant about the maintenance requirements and the equipment condition as such, because as they affect the safety of the people working around it or the people who are performing the maintenance tasks around the specific equipment. So I just want to bring that to your attention that it is a regulatory requirement. It is not something that's optional. You're not doing the maintenance just because it's nice to have, it's a must have. So that's the point. And then on 334, evidence of damage that might expose an employee to injury, the defective or damaged item shall be removed. So if you notice, or if your facility personnel notices something that's evidence of damage that might expose somebody else in harm's way, they need to remove the equipment or take appropriate measures in removing it in time without exposing the personnel to that hazard. So again, the next one is basically internal parts of electrical equipment. So this talks about, you take about electrical switchgear, or you take MCC, or you take any kind of electrical equipment. They should not be, they should be free from hard surfaces, may not be damaged or contaminated. So these are all the requirements, right? So this is directly taken out from Occupational Safety and Health Administration's CFR 1910s. The last one is if there is a defect or evidence of damage that would expose an employee to injury, the defective or damaged item shall be removed as well, right? The last slide here on this specific piece is electric equipment must be free from recognized hazards that are likely to cause death or serious physical harm to employees. And then those are from the OSHA perspective, and there is Article 205.3 maintenance requirements, which is from NFPA 70E, which talks about the equipment shall be maintained in accordance with manufacturer's instructions or industry standards, right? So there's always a question, what do we follow? So if you have the equipment manufacturer recommended guidelines, then that's your first place to go. In the absence of the manufacturer's guidelines for the equipment that's age-old equipment or something that's in 20, 30 years old, you don't have any kind of manufacturer instructions available at this time, you can always go to NFPA 70B, or you can go to ANSI, NETA, MTS standards, which gives you the guidelines for what those maintenance activities need be, right? And then the next two bullets are equipment owner or owner's designated representative shall be responsible for maintenance and documentation. So this again taken out from NFPA 70E standard. So whenever we talk to facility personnel, one thing comes out is I don't need to really worry about this equipment because my personnel are not working on this. So there are a lot of companies who outsource the work to third parties. So in that case, they think that that's their responsibility to take care of this maintenance task or take care of this safety of this equipment, which is not so, because always when someone is working at your facility, the liability or the responsibility both lies with the facility owner or the owner's appointed representative for that matter, right? So again, this is a slide that shows who is responsible for maintenance, equipment owner or owner's designated representative, and that's defined clearly in Chapter 2 of NFPA 70E, safety related maintenance requirements. So don't think or assume that once you bring in a third-party contractor, that your liability is completely waived or transferred to a third-party contractor. That's not the case. Still, the responsibility or liability lies within the facility owner or the owner's representative for that matter. So maintenance standards, so there's three different things, what I'm showing on the screen. As I talked before, there is NFPA 70B standards, which is recommended practice for electrical equipment maintenance. This is a 300 pages document. You can just go through every section, which gives from the torque values to what's the frequency of the maintenance tasks, from the reliability centered maintenance, from switchgear to medium voltage, low voltage systems, MCCs, you name it. You can't miss any type of equipment that's not in that book. Okay, the same is with the MTS standard for maintenance technical specifications again. So this document defines what those test values or the criteria, much more detailed than 70B, but it gives you more in-depth details, and also they're like NETA accredited maintenance contractors who are certified and tested to that, have the credentials to do that task. So if you are really looking at performing the maintenance task, always look for NETA, ANSI, NETA certified maintenance workers who are capable of performing those tasks. And the last one is the Z463 standard, which is towards the Canadian customers, which is a comparable standard to 70B that gives pretty much almost the same information as what is required in terms of the Canadian standards and the requirements on that. So maintenance language, the maintenance condition of, as I mentioned, that's been added in 2018 edition within NFPA 70E electrical safety standards. The state of the electrical equipment considering the manufacturer's instructions, recommendations, and applicable industry codes and standards and recommended practice, right? So this has been added because the Electrical Safety Committee or 70E identified there's a lot more to do with the equipment condition when it comes to safety of the people who are working around this equipment. That's why they introduced this, and that's the premise of this, okay? So 70B and NETA MTS, the primary reasons why you use it is basically to minimize the deterioration of the equipment, because all the standards identify the failure is inevitable, but what you do in the context to minimize that risk of failures is important. And further, by doing the proactive maintenance practices or strategies in place, you can delay this EPM by putting the EPM in place, right? Electrical Preventive Maintenance Program, what I mean by EPM here. And also it increases the return on investment, because think about a scenario where your equipment has been designed or installed for 30 years life, and you don't want that to deteriorate in 15 years because of not maintaining it properly. Just a simple stuff. So Here, what I'm showing is some of this snips of this arc flash incidents. What I'm showing on the screen is, 5,000 amps busway feeder, 10 foot long, 750 pounds. And this is from one of those Facebook's incident long time ago. It's about 7 years ago, 6 years ago, I can't recall. So that's one of the things, right? So this, because of thermal avalanche effect, where there's a temperature rise and lows in thermocycling, they call it. And then in addition to that, there is this supports of the bus bars that's been not properly anchored. So there's a lot of load on the bus bar, which led to loosening of the connections and led to the arc flash incident. And the next one here on the screen on the right is basically MCC cabinet, where you can see the bucket inside, everything in flash show, right? This is again one of those classic examples, because most people don't think that electrical equipment ever fail, because unlike the equipments on the rotating machinery, which creates a noise, these ones never make any types of noise, but they'll just give out to faults, and then it's going to be a catastrophic. And also people need to understand that when these things fail, that's going to have a significant impact on the downtime, because it's going to take down everything downstream, right? So you see a bus duct, a main bus duct, or there was like a main breaker failure, it's going to be a single point failure. So once that blows up, so automatically it's going to take down all the motors or pumps or compressors, HVAC systems, everything down the stream, unless you have a complete backup for your facility, like data center with M+2 arrangement that's going to support your 100% need. Okay, so just a simple thing, you need to just make sure that the equipments are maintained and kept in good condition. So as you look at this, is from the Hartford steam boilers. I was looking through some information. What causes electrical fires, right? So because Hartford steam boiler is the insurance company that's in the business continuity or loss continuity, which provides the insurance for the facilities level. So they looked at this, the reasons for electrical fires pretty much, and just boiled it down to the top 7 causes. So one is the heat, right? So the heat is one of the major reasons, because of the loose connections, or thermocycling, or thermal avalanche effects is what I called it. Anything that could lead to loose connection that will lead out to heat rises, that could be one reason. Lack of maintenance. They also found that equipment that's being not maintained properly, right? That's one of the reasons. Loose connections is another reason. Overloaded equipment. So equipment that's been put in place like 10 years ago, and progressively the additional load for the equipment that creates that wear and tear on that equipment, leading to that fires. That's one reason. Wiring mistakes. Wiring mistakes is anytime you have a maintenance activity performed on that machine, right? So you have a changing cables, or you have a shutdown that you're trying to make any kind of modifications to your systems, any type of mistakes, or people forgetting to tighten the torque to the torque values of the bolt connections and such, that could lead to the wiring mistakes, and that could do that. Insulation failure. This could be because of the temperature rise, adjusted cables that's been bunched together, and the heat dissipation. As a result, the insulation fails, and it could lead to that. And then the overlooked equipment, because nobody paid attention to any kind of imminent dangers. Nobody paid attention to what's going on in the equipment, because everything is working normal, and suddenly things will lead up to the fault. So these are some of the 7 things which definitely Hartford steam boiler identified as reasons. I thought that would be good information for you guys to just go and look at, because it's more like a reality check to just go and see, okay, are we looking at these areas within our equipment or maintenance strategies, and go from there. So basic stuff. This is also interesting, as I found, basic stuff to keep your electrical system safe. If you are looking from the reactive approach and trying to go after proactive approach, what are some of the basic stuff you can look at, right? If you take an electrical system, keep it clean. So you just want to make sure there's no contamination, there is no, you're not blocking the ways of your switchgear panels or your control cabinets. You're not opening these doors and keeping it open. Just make sure it's clean and tidy. That's important. Keep it cool, because you need to make sure there is no temperature rise. They're not subjected to overloads or additional stresses when it comes to load capacities. And keep it dry. Keep the connections free from moisture, and there is no, you just need to monitor the systems are all dry and intact. And last is keep it tight. It's a simple thing. Keep it clean, cool, dry, and tight. I think most of the times when you keep these 4 things looked at, I think your systems might not be failing as they would otherwise. Okay. So fundamentals of electrical equipment design. So we talked about the maintenance as a one function, safety as other function, right? So maintenance always starts even when you design your equipment. It should come even at the design phase itself. So whenever you as I mentioned on one of those previous slides, most people look at just the upfront cost of what this equipment is gonna be when making those buying decisions. So you need to just take one step backward and then look at all these 4 criteria, right? So you need to look at design for maintainability. So are this equipment designed for easy for maintenance access, performing those activities, coordinate maintenance activities, the planned production outages. So instead of just going and performing this on an ad hoc basis, you can always go and work with your production crew and making sure that these things are aligned with your coordinated planned outages, and then you can work on that. Selecting equipment considering future growth or projected loads. So if you have 1,000 amps requirement for your load, don't just go for 1,000, just go at least like 20 to 25% on a higher side, so it will support the future loads, because you don't know, like 2 years or 3 years down the line, there might be some additional loads that will be added, which would not require you to change the main infrastructure because you already looked for some additional increased capacity going into future, right? And cost of maintenance or replacement spares necessary. So whenever you look at it, take into consideration the replacement cost or the maintenance cost, or spares cost into consideration. The point I'm trying to make with this slide is the maintenance has to be considered, take into consideration the total cost of ownership, which takes all these things, what I'm showing on the screen, which will give you that. You have to make those buying decisions because you're not just going to look at initial investment alone. So that will give you the long run, your total cost of ownership will come down significantly, right? So one of the things that we specialize at this is basically identifying or monitoring the temperature anomalies. So that's one of those hot topics what we come across with our products and what we do. So this is one of the things what I'm showing here is temperature anomalies could be because of contaminated connections, as I mentioned, lack of surface area connection points, loose connections, improper grounding, incorrect crimping of connections, or cable training. So all these things could lead to any type of temperature anomalies, right? When you look at the temperature anomalies, the first thing comes into play is many facilities, as you look at, use thermography programs. I'm sure most of you also use thermography programs, which is a great tool. But if you look at thermography programs, you're going to get a snapshot using infrared thermography camera, right? You can just point this camera at an asset and you can take the temperature measurements. I think with the COVID-19, you can see it many facilities taking the temperature measurements, or the airports you travel to having this infrared cameras. It's similar stuff, but it's on a high precision side. But the difference is this one requires someone who is trained in thermography area, that is to be a certified thermographer, and they also need to take into consideration this equipment transmissivity settings and what they're trying to monitor, so that they take the accurate data that is representative of what the actual measurement is. So make sure that you're using thermography programs and your technicians are certified thermographers who are performing the task. And then there are 2 types of thermography people do. One is like a closed door thermography, where you don't expose your personnel to the hazards, where you can look at this temperature data through a window, or IR window they call it, or you can do open door thermography, where you can open the door and then you can aim this temperature, the thermography cameras to get the temperature snapshots, right? So either way you use, just make sure that your people are qualified and skilled to take this. And the biggest thing here is, whenever you use a thermography camera, you need to make sure that the system is measured or tested, replicating the normal operating condition or normal load. So if the system is loaded, is designed for 1,000 amps, for example, and the normal loading factor is like 85% of it, whenever you're performing this thermography, you need to ensure that this is loaded at 85% capacity to show the actual measurement, because you want the representative sample, not something that when everything is shut down, someone is coming and taking the temperature measurement. That's one of the things we always highlight, because you need to make sure when you call the thermography inspectors and inspection guys or your technicians going around this equipment, make sure that the systems are loaded to the real values, what they're loaded in normal situations, so it gives actual value. And then in the open door thermography, you're definitely going to have your people or the personnel exposed to the hazards. Then you're going to be on your complete arc flash suit before you open the door, and you take all the safety precautions as required to do that, right? So for other solutions, what we do here is we do something called it's condition-based or a predictive. We don't want to say the predictive because it's not predicting anything, so we'd like to say it's a condition-based tool, which is our Grayson's hotspot monitor, where you can monitor this temperature anomalies using a conductive contact type sensor that's connected to the module, temperature module here, what I'm showing on the screen. Unlike your thermography camera, you can only see what you can see through the window or through your plain side of eyes. So you can't see something because of the geometries of the switchgear, something that's been hidden within this inside of the connections and such, you can't see. So those are the areas where you can use this type of devices to monitor the temperature anomalies. Again, there's on a continual basis. There's not like a snapshot of given in time. This is more like you monitor this 24/7. You can set the threshold values and you can get the anomaly detection either sent to your DCS or a SCADA system, or you can also get it communicated to you using a maintenance dashboards. Okay, so there's a basic spec. I'm not going to go through all these things. There's a data sheet available on your download section. If you're interested, you can download it. You can go through the details. This is basically a 9-point module, 18-point module, and you can just put it in the low voltage compartment. And the coolest thing about this is you can connect this using Ethernet IP or a Modbus TCP IP, and you can gather the data to your DCS or a SCADA system. Okay, so this is how this technology works. As you see that the device emits light and it goes through this non-conductive fiber, and this ring style connector, what I'm showing on the screen, is connected to the temperature surface that you're trying to monitor. And then as the temperature changes, the light comes back to this device, and then at that point, you know the difference temperature is being logged as a temperature, and then that is communicated to your through Ethernet IP or a Modbus TCP IP as a temperature measurement, so that you can take corrective action before something chaotically fails. Okay, so just a quick comparison between the different types of thermography and open door and the IR windows and hotspot monitor. As you look at your exposure to incident energy is none in this case. In the open door thermography, you have pretty high, and then the windows, it's medium. Last is inspection frequency. Most people do thermography on an annual basis, semi-annual basis, but in this case, it's just a continuous basis. So you just put it there, and then you constantly monitor the temperature, and then you're going to attend to it if there is a problem, right? If the system tells you there's a problem of the temperature detection, then you're going to attend to it. That's pretty much it. Okay, so you can use it in wide variety of applications in MCCs, switchgear, hotspot. You can use it in electrical power distribution systems and such. In addition to that, we also have predictive maintenance tools on a panel mount node where you can bring another parameters to the same device and take everything to a single dashboard and monitor. I think all those details are on the data sheet because this is not a product presentation, so I'm going to just skip those details. Okay, if you have any questions, just feel free to ask our sales guys after the presentation. They'll be more than happy to do that. Predictive scheme and maintenance is again additional things what we look at when we take the maintenance consideration. Ensure the production is operative. Make sure your single lines are always up to date. Those are the important things when it comes to maintenance things. And lubricate and clean the protective parts clearly, and verify proper type and rating of the fuses as well, because you need to make sure that the fuses are replaced or maintained to the proper types and categories what they're used to. Testing and testing methods, right? Testing and testing methods are ways to determine whether any corrective action, maintenance or replacement is necessary for that specific asset. So that's kind of why I mentioned NETA accredited test agencies will be more than happy to help you guys out with any kind of the testing requirements to verify the contact resistance or partial discharge or any kind of predictive stuff that you want to do for your instrument. They can bring in their equipment, and they can just connect to your equipment and gather the data and give you a complete snapshot of what your equipment health condition is. That's going to be done. And also it will help you to ascertain the ability of the elements to continue to perform to design function, right? So by knowing, it's like a medical health checkup, what we do, right? So you just go and get it done once in 3 years to make sure all your system is performing to normal operation. Then if there is any preventive corrective action to be taken, then you'll go with the prescriptive procedures and then you get it done. So that's kind of similar to what I'm trying to show on the screen. And also you can chart the gradual deterioration of the equipment. So by doing the regular frequent testing and testing methods, right? So not only you're just monitoring the values of that given point in time, but by doing that on a regular basis, on a periodic basis, you can also go and baseline those values and refer those to the previous records, and then you can see whether the equipment is deteriorating with respect to the previous time you perform the maintenance check or not. So that kind of gives you a snapshot of what's going on with that. Right. So this again, I took it out few snips from the ANSI, NETA, MTA standards. There's a maintenance frequency matrix. There is this table that's pretty important, I think interesting too. The reason is how frequent you perform the maintenance, right? Most people ask me this question because again, it depends. So there is a prescribed way of how frequent this maintenance activities has to be carried out. If you're looking at NFPA 70B or ANSI NETA MTA standards, but then you need to take into consideration the two things what I'm showing on the screen. One is equipment reliability requirements. How important or critical of this equipment is for you and your operations, right? And then you look at on the top, equipment condition. So if your equipment reliability requirement is low, and then your equipment condition is good, then you don't need to perform the main. I mean, you can do it 2.5 is your correcting factor, so you can delay that for, right? So if the equipment reliability is high, and if you have poor equipment, you got to do it more often. So that's kind of the correction factor, what this is showing on the screen, that will help you to basically customize this maintenance programs or the durations or the frequencies based on not only what is prescribed, but also taking into consideration what is the actual status of your equipment and what your reliability requirements or time requirements are as relate to that specific assets itself, okay? So frequency of power system studies, this is kind of again a snapshot. So one line diagrams, short circuit studies, how often? So most people, I was talking to a few guys, and the short circuit studies has to be done 5 years since last update. So that has to be done. Coordination studies, whenever there's change in production devices. I mean, this is a very good reference tables, appendixes that you can go through to get through the details of what needs to be done and how frequent it has to be done as well. And the incident energy analysis has to be done based on the new installation of system modifications, load flow studies. I think most people do all this, but the only thing is whether they do it once in a lifetime or once in 20 years or 15 years, that's the question. So this is kind of a basic checklist that you can go and refer back to see what those requirements are as they relate to, because whenever you make any changes to a system, that's your responsibility to go and reevaluate those things to make sure your arc flash labels are correct, and then the assumptions or your coordination studies are all done properly so that you are not putting your personal or your assets in the harm's way. That's the point here, right? So frequency of maintenance test, I mean, this again, you can look through this, all this switchgear and switchboard assemblies, transformers. As I mentioned, you can't miss any type of electrical equipment from this type of document. So both on 70B or ANSI NETA MTA standards, you can look for every specific detail, every type of equipment, and they will have a prescribed time of how often and how frequent has to be done, okay? And then you take those and then you customize that based on what your availability and your requirements from the maintenance perspectives or the uptime requirements, and then you go from there, okay? So there's again another frequency of maintenance test for different types of equipment, right? So let's go to a few slides on, okay, we talked about the importance of proactive work compared to reactive work. We also looked at the importance of codes and standards, and we looked at some of those electrical anomalies like temperature, anomalies and such. So let's take a look at benefits of electrical preventive maintenance, right? So how really it helps in addressing your bottom line, right? Or your safety measures of your facility itself. So when you have a preventive maintenance program, it's going to allow you to effective scheduling of activities. So if you have everything has to start with a detailed plan. If you don't have a plan, that's not going to happen, because as I told you, with the Parkinson's law, you're going to always get your time filled up with all the activities in a given day or a given month, right? So there'll be never going to be a time for you to perform any of these activities. So effective scheduling of activities is required, for which you need to start with coming up with a thorough inventory of what your equipment is, and then identifying what those reliability information or failure data of those equipment, historical information. This has to be done with the involvement of the people who have enough knowledge of working around this equipment, so they know what's going on with this equipment on a day in, day out basis, right? So that's one of the benefits of doing that, and limiting outage impact on operations. So by doing a proper preventive maintenance practices, you're going to limit the outage impact on operations. So again, it's going to circle back to, you're going to limit your reactive work by limiting the outages, right? Because you're working on proactive measures, setting up things in place, and then you're going to minimize that, right? And then you can coordinate the spare parts. So you don't need to, by having the proper maintenance strategies, you don't need to go on a chaotic shutdown where you need to pay high premiums for expediting charges or bring the people on weekend shifts and such and pay enormous money. So it's about 3.5 to 4 times, as I can think of, what would normally you pay if you bring the equipment down in a planned outage. And you have availability of proper tools and resources. And lastly, you can also ensure that the qualified resources are aligned to work on those tasks before things shut down. So you can plan all those activities. As you look from a very top level, it's going to help you to reduce the total cost of ownership, as I mentioned, because you're going to reduce all these areas of wasting money on expediting the parts or expediting the people, working the weekend shifts and such. But all you need to do is you need to have a proper structure in place. That's very important. Without having a proper structure, you can't attend any of those. So you need to start segueing some time within your schedules to start looking at those if you don't have already one, okay? So benefits of predictive maintenance, right? So as I mentioned, predictive maintenance tools or condition-based monitor tools will greatly help you to avoid the business disruption because you're constantly monitoring the equipment status or the asset condition, and you know what's going to happen based on the criteria or the parameters what's been showing on that equipment. So you can take this, you can bring in a second equipment to basically take care of that outage. So you can have something that's on a standby purpose. You can just transfer the load and you can take this on a planned outage and you can enhance the productivity and uptime, and you can extend the equipment useful life, and you can reduce the insurance premiums and regulatory compliance, right? You can increase the regulatory compliance. You can reduce the insurance premiums because as you go low, I mean, you decrease your claims with insurance companies, you're going to see a reduction in your premium claims as well. And most insurance companies, as you know, if you have a proper condition-based tools or proactive maintenance tools available or you put in place for your equipment monitoring, that's going to get you some discounts as you look at from the insurance premiums as well, okay? So things to consider for predictive maintenance tool, right? So these are all great. So where do I start, right? So, I mean, it's not going to be easy task for you to go from a reactive mode to a proactive mode with just a flip of a switch. That's not going to happen, right? So you have to go on a step-by-step basis where you first understand the impact of the asset failure. You need to take a clear inventory of your assets, and then you need to understand the impact of the asset failure in case of unexpected shutdown. So you need to align these two things, right? So if this specific asset shuts down or trips this downstream equipment, what kind of an impact it has on my production or the people or the monies involved, right? And then you take the production downtime into consideration, and also you need to take the repair costs before and after failure, right? So if you take the costs, you need to take both the repair costs before and after failure, and available redundancy. You need to make sure that the redundant systems are available before you take down or put these things, predictive maintenance tools in place. And lastly, how long does it take to repair the asset itself comes into play, because whenever you're going to shut down, you're going to take a backup system that's going to cost you some money, and you need to coordinate all those activities to put the predictive tools in time. So that's kind of where you're going, right? So some of the common electrical parameters for predictive maintenance. So in PDM, it's a predictive maintenance. So temperature of bus bars, connections, and cables. I think most people do this thermography programs, or some use this wireless sensors and hotspot monitors. One example where you can use it to monitor the temperature anomalies. You can see the overall temperature rise of the equipment with reference to the ambient. You can also do the power quality and harmonics is other thing. Through the proper sensing tools, you can communicate all your data to a remote cloud or monitor those areas. You can see the voltage, frequency, current, and power data. You can do the contact resistance measurement. That's one of the things. So breaker event log can also be monitored, and the protective relay data can also be combined with all this predictive maintenance techniques or tools, whatever you use that. So end of the day, excuse me, you're going to correlate the data sets with the load patterns as well, right? So when you take all this information, what are you going to do? You're going to have this data correlation, and then you can make some decisions based on not just one parameter. You have multiple parameters based on different types of information that you're retrieving from these assets, and then you can make your maintenance decisions accordingly. So it's going to help you, first and foremost thing, to prioritize your tasks, right? So based on this activity or the data logging, whatever you're getting to your SCADA or DCS, you can make the decision, okay, which one requires utmost care or a criticality ranking that needs to go and worked upon, right? And then you combine that with the impact of the downtime, and then you make those decisions, okay? So again, before you go for any kind of prioritization, just make sure you do a complete inventory of your assets, gather the historical information, because that's very important, because you need to know what is the historical data of failures or the failure rates of that specific asset. That needs to be documented, that needs to be brought in, and prioritize the work based on the ranking of those elements, and used condition-based monitoring tools such as hotspot monitor or any kind of a predictive tools for you to monitor the equipment status, so you don't need to send your personnel in front of the harm's way, and quantify the assets criticality and then importance, right? So I can do it. So quantifying the assets criticality and importance is completely dependent on your facility's need or dependency on that specific asset or the equipment. Should it go chaotically shut down, right? And then justify the business case with your management, because every time when you try to justify the business case, the biggest question is, why do you need to change it, right? So everything is working as normal, and people are willing to spend 3 times or 4 times the cost of what would it take otherwise if it goes to the chaotic shutdown. So that's the reality, right? If something goes down on the production floor, people are willing to spend 4 times the cost of what it would take otherwise to proactively put some sensor on that. So just make sure that you take some pilots and just put some of those devices and show them an avoidable fault or a failure, right? So unplanned downtime that you can avoid with using all these things, that kind of gives you business justification to justify your case within your management, and then you can build up from there, okay? So equipment criticality ranking. So one of the things I want to highlight here is whenever you make the equipment criticality ranking, this is the order of priority, being the maintenance being the lowest priority to the safety being the highest on the ranking here. So most people make those criticality ranking based on the maintenance cost of the production loss, but I would challenge you to go and look from the other side of this bottom, which is the safety, customer, quality, because these things, once you lose it, it's going to cost you millions of dollars in the customer satisfaction or worker compensations when it's a safety issue, or reputation of the company, or the product quality comes down bad, right? So make sure that you think on that end, not just get too much worried about your production loss and the maintenance cost alone, because those are probably very small in dollar value when compared to the big ones, which is like a safety, customer satisfaction, quality. Just look into that, right? So benefits of, again, predictive maintenance, there are 2 angles to it. One is the economic standpoint, one is the safety standpoint. From the economic standpoint, it provides you the ample time for evaluation, identify the long lead parts, reduce downtime, lastly, avoid chaos. From the safety standpoint, it's less interaction with the equipment, right? So whenever you have the sensors and tools available, you're less interacting with the equipment, you're doing the maintenance on demand, you are reducing the exposure of your personal hazard to the hazards way, and then there's no maintenance induced breakdowns as well. And then lastly, you also adhere to the codes and standards, because most of the stuff what you're talking about in the predictive or condition-based tools are already identified in NFPA 70B, or it's also identified, I think, in the ANSI NETA MTS standards. That's kind of where it is, right? So so this is my favorite slide, where it combined both maintenance, reliability, and safety all together. So as you see in the slide, so maintenance is the bottom layer, reliability is the second, and safety is the top layer. So proper maintenance strategies improve the overall equipment effectiveness, and then the improving the equipment reliability on the second layer results in the higher productivity, which is your plant uptime, productivity, and the metrics are concerned. And the last one is reliability. Reliable plant is a safe plant, and a safe plant is a profitable plant, because by doing proper maintenance strategies, you sustain by reliability, and the safety sustains reliability. So safety is on the top of the pyramid, and the maintenance is the bottom layer. So whenever you try to look at things, look at from that angle. By doing the maintenance activities, you improve reliability. By improving reliability, you improve the safety. That's pretty much it. And then these are the references, as I mentioned, 70E, 70B standards, and ANSI NETA MTS. And this is my email. If you have questions, concerns, or comments, please feel free to reach out to me, and also take an exit survey as we exit the webinar. And I think I have 6 more minutes to take any questions. Yeah, and there's a lot of stuff in this. Again, as I mentioned, this is not supposed to be a detailed electrical maintenance webinar. It's a fundamentals and overview, and giving a compelling case of going from a reactive mode to proactive mode when it comes to electrical equipment maintenance, and the importance of codes and standards and safety needs, and how to start that. Okay. Let's see if I have any questions. I don't see any questions here. So there's only 2 things, as I know. So one, it's completely clear, or it's as clear as mud. So I will just stay online for oh, there's a lot of questions here. Let me see this. Oh, I think I'm having a problem here. Okay, that's good. So, okay, how do you get the volume to work? I didn't understand the question. How do you get the volume to work? Okay, that's probably not. We'll get a link to the recording of session. Yes, the webinar has been recorded and you will get a link. If you have not gotten a chance to watch the presentation live, there'll be a recorded link. Nick will send it out. Just for a clarification, this is applicable under 29 CFR 1926. I think everything is applicable under 1910. That's for the electrical equipment maintenance and the safety comes into play. That's all 29 CFR 1910. Can you send links for this? Absolutely. As I said, we'll follow up this presentation. Maybe today or tomorrow, Nick will send out a PDF version of the presentation for you to refer back to. Okay, happy holidays, happy new year, happy holidays everyone, happy new year. I'm live streaming from India right now, from Hyderabad, India. It's 10:30 p.m. local time. Got the question, answer to question 2. Can we get the copy of the presentation? Yes. Tick, tick, tick. Talk about. Audio recordings, we'll send it to everyone who attended. Do you use sensors in predictive maintenance, preventive maintenance? So predictive maintenance absolutely uses some type of a sensor-based technology for you to connect it permanent to the equipment, and then from there it automatically sends the data to your systems. So in that way, you don't need to go and perform route-based inspections, or you can reduce your route-based inspections because you're constantly monitoring it on a remote basis. Okay. When you generate a site visit report, besides the deficiencies that you have found, do you include any OSHA standards in the report? No, not necessarily. You don't need to record any OSHA standards in the references, as long as you tie that back to 70B standards or ANSI NETA specific sections. I think that would suffice. Does Grace do much work in the USA? Absolutely. Grace does a lot of work in the USA, and we have office in Davenport, Iowa. And I think you can reach out to our office and we'll be more than happy to help you out with it. We're a US-based company. I'm currently visiting India. So that's a clarification. I think whoever has participated in this session will get their CEU credits or the certificates for attendance. That will be done as part of the follow-up as well. I think Nick will follow up that with you, or it should be there already for you to download, if I'm not wrong. So what are some upcoming webinars? Michael, okay, so we're just working on something on arc flash PPE next month, and also we'll have electrical safety panel. We're working on our webinar plan for next year as we speak. So stay tuned, and we'll be in touch and we'll be in communication for the upcoming webinars. So normally we try to give like a 3 weeks or 4 weeks notice of any webinar that we do, and sometimes we'll give only 2 weeks just because from this planning standpoint, it's difficult to get speakers and also get some good topics that's in alignment with what we do here and our specialization. So yeah, please stay tuned and follow our hump day, and that's one of the areas where you can subscribe and you can get a lot of this information on a regular basis. It's a great question. I'd like to thank you, Hector, and all the Grace Technologies team for promoting electrical safety throughout this strange year. I hope we work with you guys in 2021 promoting electrical safety. Thanks, Alejandro. Yeah, we would look forward to work with you. And as I mentioned, right, so if you have any questions that's not related to the product, but still a safety related question, or if you have any questions around preventive maintenance or what you need to be doing, if you have any questions as well, just please feel free to reach out to us. We do have a panel of safety experts and subject matter experts available, so we'll be more than happy to at least connect you with them to solve your problem. Doesn't necessarily need to be a product sell. We'll be more than happy to solve your any application problems that we are willing to help you. Okay. All right. It's 11 o'clock Central Time and it's 10:30 p.m. India. I don't see any additional questions coming through. So with that, if you have any additional questions, you have my email ID. You can reach out to me and send a note to me. And please do take exit survey and give us your feedback and download the data sheets, what you have on the handout section as well. So if there's anything that we can help you with temperature monitoring or predictive maintenance, please feel free to reach out to us. Thank you so much, and happy holidays and happy new year. And thank you for the attendance and everything what you guys do. Okay, bye-bye. And see, quit, end the webinar for all. Yes.